So talking about the curvilinear motion for rectangular components, so occasionally the motion of a particle can best be described along a path that can be expressed in terms of the x and yz coordinates. So like what I've mentioned kanina sa general curvilinear motion, when you describe the motion of a particle moving along a curved path, it is convenient to describe in three-dimensional. So when I say three-dimensional, that is in representing in terms of x and x, y, z coordinates. So kaning x, y, z coordinates, these are what we call rectangular components. But in some cases, sa atong problem, especially sa atong example problems later, we focus on the two-dimensional. Okay? Ang three-dimensional is ma-encounter na siya kung moabot ta sa subtopic na cylindrical motion. Kaya mas gamit ang cylindrical coordinates when we encounter a three-dimensional problem. So I had one example na for three-dimensional, especially for cylindrical coordinates. And talking about the geometric aspect, we start with the position. So if the particle is at point XYZ, so mo niya to ang koan, in three-dimensional, on the curved path S, shown in the figure below, so then its location is defined by the position vector. So that is represented with your vector R. So your vector R is the position vector that is equal to xi plus yj plus zk. So this is in written in a vector form, in a ijk format. So that is in, ang x is for the unit vector I, y is for the unit vector j, and your z is for your unit vector k. And when the particle moves, the xyz components of your position vector r will be functions of time. So your x will be equal to your x with respect to the time, the same with your y and z components, so that your position vector r will be equal to rt. So this components sa imohang particle, which are the x, y, z, are based from the function of time. And at any instant, the magnitude of r is actually defined by using this formula. So that is r is equal to square root of x squared plus y squared plus z squared. And the direction of r is specified by the unit vector, which is equal to your vector, position vector r over its magnitude, which is which can be found from the formula above. Next is the velocity. So this is another geometric aspect. So the first time derivative of your r yields the velocity of your particle, hence that is represented in this equation. So when you differentiate the position vector r kanina with respect to time, you will derive with the velocity, the vector velocity, and it is defined with vxi plus vyj plus vzk. So vx, vy, and vc, these are the three rectangular components of your velocity. And the velocity, the x component sa ibang velocity is the first derivative of your x with respect to time, the same with your y component of your velocity, which is vy, and also the z component of your velocity, which is your vz. So if you notice, naka-dot siya, may dot sa taas, it means that that is a first derivative, and this is what we call dot notation. Okay? So, kung dot notation, um, this is very common for kanang analyzing velocity and acceleration. Kay kung dot notation manggod is kutob lang siya duha ka buok, duha ka dots above. So kung duha meaning second derivative, wala na'y tulo ka dots or 4 or 5 or so on and so forth kung dot notation. So kung naay dot sa taas sa imong letter, that form is what we call a dot notation. So depende kung pila ka dots. So kung isa lang ka dot, it means that it is first derivative of that particular component with respect to time. And kung duha ka dot, that is the second derivative of that component with respect to time. So it is, you derive always the component with respect to time. And for that, the dot notations, what I mentioned, this dot notation represents the first time derivatives of your position vectors, the components of your position vector R, which are x, y, and z respectively. So this is the vector form of your velocity. So that is vxi plus vyj plus vzk. And what I mentioned kanina sa general curvilinear motion, the velocity is tangent sa imong curve path. So that's why mao na ang location sa imong velocity sa imong particle. And from the vector form sa imong velocity, the velocity has a magnitude that is found from this formula. So that is the sum of the squares of your components, tapos square root. And a direction that is specified also by the unit vector. So that is the position vector v, or the vector velocity rather, over the magnitude of your velocity, which can be found by the formula above. And the last one is the acceleration. This is the other geometric aspect to describe the curvilinear motion. So the acceleration of the particle is actually obtained by taking the first time derivative of your velocity. So atong velocity vector nimo, you just differentiate that with respect to the time, or you can also use the position vector r, pero naka-second derivative ka ana with respect to time gihapon. Hence, your acceleration is equal to the derivative of your velocity vector with respect to time, so that is dv over dt, is equal to axi plus ayj plus azk. And mao na ang representation sa dot notation. Ang first dot notation sa imong velocity sa three components sa imong velocity, that is equivalent on the components sa imong acceleration, or it could be the second dot notation sa imong component sa position vector, which is the x, y, and the z. So that's why kung isa ka dot, meaning first derivative lang. Kung duha ka dot, that is second derivative, or kaduha ka mag differentiate. And here, ax, ay, az are represented respectively, and the first time derivatives of vx, vy, vc, or the second time derivatives of your functions x, y, and z, dira nimo kuha ang components sa imuhang accelerations, which are AX, AY, and AZ. And this is the illustration of your acceleration sa imuhang particle. And what I've mentioned kanina, your acceleration is not tangent sa imuhang curve. Unlike sa velocity, sa previous slide, the velocity is tangent to the curve, but the acceleration is not tangent sa imuhang curve path. And from this, you can determine the magnitude of your acceleration based on your vector form sa imuhang A, which is AXI plus AYJ plus AZK. So you just determine the square root of AX squared plus AY squared plus AZ squared. And a direction specified by the unit vector, that is the acceleration vector over its magnitude. And since the acceleration represents the time rate of change in both the magnitude and direction of the velocity, in general, like what I've mentioned kanina, acceleration will not be tangent to the path. So in this, kung mag-describe kag motion sa isa ka particle moving along a curved path using rectangular components, what you will do is you just represent the motion of your particle using the rectangular components. So that is naka X, Y, and Z components. So when we talk about rectangular, that is X, Y, and Z. Pero in our example problem, kay two-dimensional lang siya, so therefore we consider only, or we consider that the particle is acting only on the XY plane. Kay what I mentioned kanina manggod, kung three-dimensional, napay other way for you to describe the curvilinear motion of the particle, that is what we call the cylindrical coordinates, which I will discuss that in the future. So just a procedure for analysis. What you will do when you use rectangular components, you describe the coordinate system. So a rectangular coordinate system can be used to solve problems for which the motion can conveniently be expressed in terms of its XYZ components. And afterwards, you apply the kinematic equations. So since rectilinear motion occurs along each coordinate axis, the motion along each axis is found using these two kinematic equations. V is equal to ds over dt and A is equal to dv over dt. Or in any case where the motion is not expressed as a function of time, the equation, the third kinematic equation, which is AdS is equal to VdV, can be used. In two dimensions, the equation of the path, which is y is equal to the function of x, as a function of x, can be used to relate the x and y components of velocity and acceleration by applying the chain rule of calculus. So ang atoa, for the first problem na akong i-discuss karon, what we need is ang first example rather, kay each component manggod is described with respect to time. Pero sa second problem, kay wala man siya naka-express or wala siya gi-describe as a function of time. So for that, if ever the equation of the path is described by y is equal to the function of x, so for that, parang ma-determine nato ang x and y components of velocity and acceleration, we need to apply the chain rule of calculus, which most likely ma-discuss nato in the next class schedule nato. And once the XYZ components of V and A have been determined, the magnitudes of these vectors can be found from the Pythagorean theorem. So atong i-mention nako na naka-Pythagorean theorem sa mga velocity and acceleration, and their coordinate direction angles from the components of their unit vectors.